Hello, this is William Reed. I'm an AP student, an AP Physics student at Michigan Virtual High School, and today I'm going to talk to you about Newton's third law of motion, and I'm going to prove it with a model rocket. So, first off, let me explain to you what a model rocket is. It's obviously a rocket, but how it works is, alright, it is set up like this. It looks like a normal rocket. And then it's got, fins on it that go down to the side. And then it also, on the bottom, always has a rocket engine. This rocket engine is full of a mixture that contains sulfur, among other things, and gunpowder. And so what it does is you have your rocket connected to a circuit with a battery on it, and it also has a switch on it. So when there's also an igniter strip in the rocket right in here. So when you close this switch, the igniter strip, the cord wire basically gets hot, and then it ignites the igniter strip, and it ignites the engine, and the rocket goes up into the air, pushing on the gas underneath it, which proves Newton's third law, which states that for every action there's an equal and opposite reaction. So for every force there's another force pushing back on it. So for example, I'm sitting in a chair, so my body is pushing down on the chair, and the chair is pushing back up on me. So there's an equal and opposite force. So what the rocket does is, as it is going up into the air, so as it is going up this way, it is pushing down on whatever gases and heat the engine makes. So it's pushing down on the gases and heat. So what's happening is the gases are pushing back up on it, which propels the rocket into the air. So now that that's covered, let's work out the math on it. So I did weigh my rocket. I'm using A83 engines in my rocket, and with the A83 engine, the mass of the rocket, so MASS equals, it's about 0.62 kilograms. So 0.62 kg. So after I found that, then you have to find the thrust, which I have not done the experiment yet. So the thrust is going to be shown from this chart I found on SCsRockets.com with their A8 engines right there. I'm going to say it's about 2.2 newtons, just because it goes up to 10 newtons, but that's before the rocket's really in the air. So when I'm going to be tracking it is after it's in the air. So to find the acceleration, I'm going to use it at about 2.2 newtons. So we'll go back to our notes and we'll do thrust, THRUST equals 2.2 newtons. 2.2 newtons. Alright, and then now what we need to find is the force of gravity. So, gravity, little g, on the planet Earth is 9.8 meters per second per second. So because the gravity is pulling down on the rocket in a negative direction as opposed to where the rocket is going, we're going to call it negative 9 meters per second per second. And keep in mind, we are neglecting air resistance. We're not using that. We're not looking at it. That involves different formulas that we're not going to get into. So to find the force of gravity, we're going to multiply the mass times the acceleration, because force equals mass times acceleration. So we do 0.0. Whoa, that was interesting, wasn't it? I'm gonna go back and erase that. We get 0.062 kilograms which is the mass of the rocket, times negative 9.8 meters per second. Negative 9.8 meters per second. Alright, and that comes out to equal, whoa, that comes out to equal about negative 0.6076 newtons. Negative 0.6076 newtons. So that is our gravity. So now we're going to go and find what the we're going to add our thrust to our gravity to find our total force. So we're going to add our thrust of 2.2 newtons to our gravity of negative 0.6076 newtons. So once we add those together, we get 1.5924 newtons. And that is the net force. So if we were to draw a free body diagram of the rocket, so here's the rocket, the gravity is pulling down, but not at as much of a force, and the rocket is also pushing down the same force, but the gases are pushing up on the rocket with a force of 1.5924 newtons. So our net, the net force, so the force that is greater when you add all the forces together. So when you subtract the force of gravity from the force of the gases pushing up on the rocket, our net force pushing up is 1.5924 newtons. So now all there's left to find is the acceleration. So force equals mass times acceleration, which is one of Newton's laws. And what we're going to do is we're going to put our force, which is 1.5924. I'm doing a green. 1.5924 newtons equals mass of 0.062 kilograms. 0.062 kg times acceleration, which will be meters per second. After you multiply all that out, you get an acceleration of around 25.683 meters per second. A equals 25.683 meters per second. Alright, and as I said before, what happens is as the rocket pushes down on the gases push back up on the rocket, which accelerates the rocket into the air. So after all that, why don't we take a look at the calculations after I run the experiment. Thank you, and goodbye.